Well, welcome to the Masters of Engineering podcast. Cool products, the people who develop them, and how they do it. I'm John Hirschtick. I'm Chief Evangelist here at PTC. I'm also the former co-founder and CEO of Onshape and SolidWorks. I've spent my life building CAD and PDM and other software tools for product developers. But the best part of my job is I get to meet some of our users, and they're the coolest, smartest product developers in the world. I learn a lot from them. And in this podcast, you get to meet them and learn from them too. So our guest today builds very cool, special robots. She is Samantha Johnson. She is the founder and CEO of Tatum Robotics here in Boston, Massachusetts, USA. Samantha, welcome to the podcast.
Thank you so much for having me. I'm looking forward to it.
Well, I'm really excited to have you here because I have never seen or heard of anything like your product. Can you tell us what you're doing at Tatum, what the product is?
We are developing the first independent communication tool for people with deaf blindness. So these are people who cannot hear nor see. So they communicate through tactile signing. So you might be familiar with deaf people signing. They sign to one another using their hands, their facial expressions. Well, deafblind people, because they cannot see, they hold on to the hands of their communication partners and receive the signs directly into their hands. But you can imagine, because of that interaction with their communication partner, they don't have a means of communicating that way independently. So if they're at home, if they're without an interpreter or a communication partner who can sign, they're unable to access communication. So what we're developing is a highly anthropomorphic, collaborative robotic arm that deafblind people hold on to like they would an interpreter to receive any form of communication, whether that be an email, a book, news source, website. And they can all access it on their own time and customize their experience that way.
That is so amazing to me. When I saw your product I just saw it on a website. I haven't seen it physically yet. I just, just first of all, I didn't really know how deafblind people communicated. I'm just saying, so there is today for deafblind people, there's no other technology solution that does something like this.
Yeah, so some deafblind people do make use of braille. So braille is a medium of English. So just as English has capital letters, certain word order, punctuation, so does braille. But they would say maybe less than 10% of deafblind people use braille. So for that remaining 90% of deafblind folks, they don't have independent communication currently. And they don't especially have it in their primary conversational language. So right now, if a deafblind person wanted to use braille, they'd have to learn a whole new language, because ASL and English are two completely different languages. They'd have to actually learn this new language to use braille, and then actually learn to actually receive braille through those raised dots. So right now, what we want to do is really prioritize that language they're already familiar with and what they're comfortable using, while now introducing this novel technology that prioritizes that.
And there's no tech available to them to do this. It's not like you're making a lighter or faster version. There just is nothing for them to go buy that would do something like this today.
Exactly. So it's been a really fun design challenge because there is no existing technology as that precedent. So every design decision we make needs to be heavily validated. So we work with a lot of deafblind groups here in Boston, whether that be the Deafblind Contact Center, which is actually where this project stemmed from, or we go to the Helen Keller National Center, the Perkins School, because we really need to make sure that this device works for all deafblind folks. And we can use a lot of rapid prototyping to design a lot of various different prototypes and see what works best. So over the past few years, we've had so many different versions and have really been now fine tuning to really see what works best.
And how did you personally, how did you get connected with this problem? You're not deafblind yourself, so how did this come about?
So I actually, during my undergrad at Northeastern University here in Boston as well, I had taken an American Sign Language class. I went to college because I knew I wanted to do assistive technology, and I took the signing class because I thought it would maybe be beneficial when I went into that space. And part of the class is you go out to deaf events in the community to learn more about the culture and practice your signing. And on one of these events, I met a deafblind woman through the Deafblind Contact Center in Boston. And I was amazed by the amount of information she could receive directly into her hands. And we got to chatting through an interpreter at the time. And I asked very, very clearly, just how would you communicate if this interpreter wasn't here? if you were at home, how do you communicate? And she says, I don't. If I'm at home, I'm home alone. I have no means of accessing communication. And I was immediately inspired to kind of create some sort of solution for this clear problem of just isolation and loneliness. But I really didn't, I was a sophomore in my undergrad. I didn't have the time or really the skills to do anything at the time. And but I kept up with the community and the Deafblind Contact Center. And then years later during COVID, I started reading these articles that were coming out about the deafblind experience during COVID, when all of us were obviously struggling with isolation. As you can imagine, this was really exacerbated for the deafblind community, who relies on that sense of touch. And because of social distancing, they now couldn't even access interpreting services. So more than ever, this complete lack of communication tools was really prevalent. And so I'd reached out to the Deafblind Contact Center in Boston and asked, what can I do? Is there anything I can do? And we started coming up with possible solutions. And I ended up starting this project as my master's thesis at Northeastern. And then once I graduated, I got a real slew of support from the deafblind community. And actually, the Canadian National Institute for the Blind reached out and gave us our first bit of funding to actually launch the company from there.
So you're an undergraduate in college. You're not an experienced product developer or manager or anything. You have this idea and you just decide to build it because of the need in the world. So this wasn't like, someone hired you and paid you something or whatever. So it's so motivating to hear that. It's such a wonderful story. But just to be clear here, you had no formal experience building a product before of any sort, really.
Yeah, so I had done some previous work. I worked at Johnson and Johnson, and I worked at the Perkins School doing some product development, but not in the robotics space. So I previously worked as a product development engineer, but robotics were new to me at the time. And I moved into robotics space because that was the solution. I had this problem and the solution was going to be robotics. So that's when I really started learning kind of all that needs to be in that space, moving away from product development, which was what my experience was in, and then moving towards robotics.
And the language that the robot and that today the deafblind translators use, the hand to hand, so they literally sit with the deafblind person and hold hands or touch hands. Is it the same as American Sign Language, or is it a different dialect variant?
Yeah, that's a great question. And it's a very nuanced answer as well. So it is a variant of American Sign Language. But as we mentioned, American Sign Language uses the face a lot. So if you were to ask a question, you might move your eyebrows in a way to show that I'm asking a question instead of making a statement. But for deafblind folks, they can't see your face, right? So then you modify the sign. So there's a question wiggle that you would use instead of kind of having that facial expression. Or you might, instead of, making something really big, you might make it more clear by using this modification in Tactile ASL. But what's really interesting with ASL as well is there's a lot of variants even within that. There's, signing that's a little bit more Englishy, case, or more pigeon style. So there's a lot of variants that we do try to capture with our device as well.
And so the language, the tactile sign language, is similar but not identical to American Sign Language. And now you have a robot, and I want to remind people you're listening to Masters of Engineering. Our guest today, Samantha Johnson, founder and CEO of Tatum Robotics. And if you want to see images of the Tatum Robotics, it's the T1, right? Is the robot name. On the website, there's images, but it looks like a robotic hand sort of mounted on a almost like a trophy mount, like a tabletop. Is that a way to describe it? So it sticks up in space. And so that's the hardware is the robot, but how big a breakthrough is the translation technology that you must have or license? I'm curious to know, where does that come from, the ability to take speech or text and turn it into the sign language?
Yeah, so this project has really grown in what we thought we were able to accomplish. So when I started this as my master's thesis, I had originally expected it to be more of a software challenge, just, mapping signs onto a robotic hand that I would assume I could take off the shelf. But quickly we realized that the hardware actually needed to be quite specific as well. The hand needed to be exceedingly dexterous in order to achieve all the hand shapes for American Sign Language. And not only that, it needed to be above anything compliant, because these deafblind people are going to be in contact with it at all times. As you mentioned, we can't have, open linkages along the back profile that they could get stuck in, or hard metal flanges that could cause damage. So we ended up designing our own hardware component. And then as we got further down that path, then we really realized what depth this communication translation was going to be as well. So as we mentioned, ASL and English are two completely different languages, and there is no Google Translate now for English and ASL. That doesn't currently exist. So we actually have linguists here. We work with deafblind folks, native signers, to really develop that translation piece. So we have, and as we mentioned, it needs to translate into various outputs as well, or dialects. So not everybody signs the same way. It varies based on people's education, based on their regional differences. So not only is there grammar difference, but even the signs they may use are different. So as this project, as we learn more about it, and as we kind of talk to more deafblind people, the more we see these very specific needs come up, and we start to understand how we need to rescope the project accordingly.
And so you're building the software that takes text or sound, is that right? Either?
Yep. So
And so,
any
yeah.
yeah, so any sort of English input, whether you talk into it or you could type into it, or again, like pull a book or news source offline. And then, so our whole system is cloud-based, which allows us not only to access all of these materials, but then allows us in the cloud to translate it, and it gives us that customizable option. So as a deafblind person, when they receive the device, there's a little bit of setup in that the deafblind person can pick what speeds they want, what hand formations they want. They can put in what region they're located, so we can try to customize their experience. And then it translates it and then essentially streams those signs down to that robotic arm that you mentioned. It's not a wearable. This is a standalone
Yeah, it's a
robotic arm.
standalone, it's a tabletop device. And you build the software too. This is fascinating to me that you're able to do both the robot, which is amazing, this articulating hand that, as you say, has to come in contact with human hands. So that's a huge safety and tactile experience. So that I want to get to the robot, but the software is also amazing to me that you didn't, I kind of expected you to say, well, there's an open source translator and we just kind of plug it in. But no, you're building the software too. So
Yeah,
you're
that would definitely have made our lives easier if they'd already
yeah, but no,
existed.
you're
But
building the software.
yeah,
Wow, fantastic. And I love that you said cloud native and cloud based. You know, I'm all about that. I believe that's, you know, a huge advantage for most any kind of software these days. So what has been the biggest challenge? You've mentioned some of the challenges, but what's the biggest challenge on either the software or the hardware side?
yeah, I would say the biggest challenge is really designing for a group of people that have not been designed for. So some simple things that we take for granted when we design, of even just like a simple user interface. We can't just use a touch screen. They're not going to be able to make use of that. How do we allow them to interact with the device? Or one of our early validations, we built an early robotic arm, and the deafblind people came and held onto it and put a lot of weight on it. They're not familiar with technology. The technology has not been made for them. So you and I might have even when you're like putting a screw in, you have an idea of when it's seated. You have that kind of understanding. That when new engineers come in, they don't have that, and you need to teach that skill. It's like the same idea with now this technology of the deafblind people come and they put their whole weight on it. They think it's like Iron Man's arm, and we're like, how do we communicate with them that they're putting too much weight on it, and without using, visual or audio cues? So it's been a really fun challenge of how can we manipulate haptics in a variety of ways in order to convey different things, and what can we make customizable so that it can really work for a wide variance of people's skill levels. So if somebody's a really experienced tactile user, what do they need that's different than someone who's just learning tactile ASL now? So there's been a lot of challenges really trying to really be more holistic with our design. But as you know, you got to start somewhere and really build up. So that's really what we've been doing. Now that we've been working with a lot in the Boston community, and just recently now we were just at the Helen Keller National Center last week, trying to understand, okay, now that we move out of Boston, does this still work for the folks who are learning ASL at the Helen Keller National Center? What differences do we see? So that we can start kind of pulling those questions in as well.
So where are you in the journey? Are people using the device yet?
So far we've tested the device with probably now about like 40 deafblind folks. And these have been either in our office or going to areas. So, we went to Connecticut, we went to New York to test out the device. But what we're actually ramping up for now is in August, we're starting a beta pilot. So we're actually going to be giving a number of these devices to deafblind folks to use for 8 to 12 weeks. So we can actually see it being used in the use case. So we're giving them to use in their homes, so we can see when they use it, what do they use it for? What length of time do they use it for? Does that something break? Why does it break? When? And so we can really start answering some of those questions that we can't always answer so clearly when I'm standing right next to the device, making sure that it works.
So, so you're in testing, you're in kind of a pre-release testing, and then you're going to what I might think of as like a beta test release where you're not yet selling it, but you're going to put it in customers' hands. So, but you have had people use it in test situations. What kind of reactions do you get from the deafblind people?
Yeah, as you can imagine, it's pretty inspiring to and that's really probably my favorite part of the job and probably my team's as well, is the excitement you see from these deafblind people. You're getting more hugs than you've ever received, and the most genuine hugs. We have people crying in our office. Somebody's talking about, like, she's in tears and she's like, I'm not sad. I'm just so excited to have one of these one day. One woman tried to steal it off my table and bring it home with her.
Oh,
So
oh, wow.
it's something that we see. What's really, really interesting is even some of the folks we have in Boston that they've been working with us for years on this. Every time we add in a new feature, like we just added in that user interface, you get the same hugs, you get the same excitement. I think as it gets more and more real for them, I think it just becomes more exciting. Outside of a master's student at Northeastern, it can do some simple shapes, and now it's really signing and they can use it themselves. I think it's really becoming more realistic that they could actually have this really soon.
Oh, wow. So yeah, I think that a lot of people build products that touch people's lives, but you're really touching people's lives in such a dramatic way for people that have had few things. It sounds like that are no things that can do this for them. It's really um, uh, remarkable. Like, for instance, I meet product developers. We have Onshape users and customers in prosthetics. And there it's often about doing better. Like, well, there's an existing prosthetic, but we've made an improvement to it. And there's some really great, and they're huge improvements in all kinds of dimensions of prosthetics, aspects of prosthetics that I've met. But it's not like they never existed before. Is there any thought to making it a two-way thing? Like right now, as I understand it, you can hear or process text. Will there ever be a way that the deafblind person can broadcast, can send a message?
Yeah, absolutely. And that's something that we really wanted to make sure was possible, because we didn't want to put all the conversational burden on one side. They can receive this email, but then they can't actually reply. So we have a number of kind of layers to that solution. So first, we have a number of kind of on the buttons that click quick replies, we call them. Then also we have a gesture recognition interface. So this is a technology that a lot of companies are working on. And so we have a small team here that's working on it just for right now. So the deafblind people can, finger spell back and they can give proper responses, or they can use that as a way of interacting with the device itself. Instead of clicking the button to read a book, they can actually sign to the device, I want to read a book.
I see. Using visual, you don't need the they can sign visually. You
Exactly.
don't
So they'll
need the
sign visually.
tactile for that,
Yeah, exactly.
because they can broadcast so you would use a visual, like a camera system to do that.
Exactly. So we have a
Fascinating.
camera embedded into the system that allows them to respond. But again, so many amazing companies are working on this technology that we have a small team here that's working on the system for now. But at one point, really soon, we could really partner with one of these organizations, and that will allow even greater, uses for that two-way.
So be conversational. Oh, that's
Exactly. Exactly.
so cool. Tell me about your process. You mentioned earlier doing lots of rapid prototyping and all that. You probably tell me about your process, and in particular, are there ways you're going about building the Tatum Robotic, the T1, as you call it, the T1, right? Are there ways you're going about the process of building it that are different, is in addition to, of course, the product being different?
Yeah, I think something that we're always taking into account is that idea of safety. That is kind of our number one kind of priority. So as we're building, we want to really put flexibles wherever we can. So wherever we possible. Right now, for our small scale projects, we just use 3D printed TPU. And what's exciting now is really now moving more into that casting sphere of really getting some nice molds. But we've tried to put flexibles wherever possible, or joints. We try to make out of flexibles all of our kind of profiles that the deafblind people are going to be holding on to. We try to make out of flexibles. So it's really this really interesting robotic arm, because there's nothing really hard or solid in it. What's also a bit of a challenge is this device cannot be this very exciting $30,000 robot arm, because then no one would be able to access it. This is something that not only does it need to have 18 degrees of freedom in this system and be cloud based and have all these customized, it also needs to sit at a price point that's accessible for deafblind people. So we really do make use of a lot of low cost manufacturing. We try to, make the system work as much as possible using the inbuilt functionality of the actuators that we're using, or try to find a lot of 2-for-1 uses of embedded systems so that we can keep this device really low cost. So what we often do is we, figure out what works and then figure out how we can make it cheaper. Or the main process that we do is actually we design as small as possible and then grow. So the first system we had actually only had 3 degrees of freedom in your index and middle finger. And then slowly we realized, oh, we actually need that in all of the fingers. But, oh, do we need all 4 joints? Nope, we can just do 3. So we started adding in these features as we see them, so that we just don't start by developing this, $30,000 robot and have to cut back always. We can start really small and start adding in those functionalities as we see fit, and either to make the longevity longer or to make the use cases a little bit more easily and more fluid. So it's been a really exciting design process that we have, as you could imagine, a growing team in order to do all of this software, embedded systems, linguistics, hardware design, in order to really have a lot of hands in working on this.
And how many people are on your team?
So right now we have about 6 people working full time.
6 people doing all this.
These are some hardworking 6
Wow.
people, I can tell you.
I'm going to say, I hope our listeners are hearing all that you're doing with 6 people. That's amazing.
Yeah, and a lot of them even are just master's students at Northeastern. We make use of a lot of co-ops. So we have 2 co-ops from Northeastern who are working hard as well, putting all their
Northeastern, Northeastern co-ops are fantastic. In my opinion, I've run into them in industry, and we've had some of them here where I work at PTC. If I go to the software side of the house, would you say are you using a process on the software side? Are you using something like Agile Process for the software? Is that right? Sprints, scrums, daily stand-ups. Is that kind of part of your world on the software side?
Yeah, so we pretty much do kind of weekly sprints, is kind of, even on the hardware side too, is something that when we got started, you can really get lost in the idea that there's so much to do, because we're building pretty much everything from the ground up. There's nothing that we're pulling in. We're not using another person's hardware, we're not using other person's hardware. So we're starting everything from the ground up. So it's really easy to kind of get stuck in this circle of we're really just working towards something, but we don't know action items along the way. So we've kind of used weekly sprints for pretty much all of that we've been working on.
Weekly sprints. So you use weekly sprints for your hardware as well as your software.
Yeah, and that's
a powerful thing for our audience to hear.
Yeah, and I think it's something that at first my mechanical engineers were like, there's nothing we can get done in a week. And I think
I hear that a lot in hardware. We can't use Agile for hardware, in 1 week or even a 3-week sprint. No, we can't do it. Yeah. Okay, go on. Sorry.
Yeah, but I think I think having those weekly goals and having these idea that you can get a lot done in a week. There's a lot of hours in a week, especially now, Bamboo 3D prints, we can have those. You can have those by the afternoon if you get the print started in the morning.
What 3D prints did you say?
The Bamboo printer. It's
Bamboo printer.
Fast.
Oh, it's a particular printer.
Yeah, we're located here at Mass Robotics, which has a booming facility of kind of the cutting edge 3D printers. So we can make use of a lot of this functionality that even our mechanical engineers, I think maybe ask them later, but I would even say that they'd argue that the weekly sprints are really helpful to kind of keep them focused and really make sure that things get done every week and that we can see progress moving forward.
Weekly sprints. So you would call it an agile process, fair to say? And that's awesome. In terms of the tools you use, what do you use on the software side to run?
So we build out all of our custom APIs, SQL servers. We're building everything from the ground up. We're writing everything in C#. Our software engineer likes to have great control over everything that we're developing. And what's great is the servos that we're using are Dynamexel servos, and they have a lot of built-in SDKs. They're built by Robotics, and they're a great product line because they have a lot of great built-in functionalities. We can not only position control like a traditional servo, but we can monitor the velocity, we can control the current, we can control the trajectories. So we can use those SDKs that are built and pull those into our software. And then
you're controlling motors in the cloud. So when you said you use the cloud, I kind of thought for like general instructions, but you're down to the motor controller level.
So all that really lives on the robot itself is turn the servo essentially. But everything else, all of the command instruction, all the math in the back end is all done in
Wow.
and just so it's really a thin client that lives on the robot itself.
Very thin client.
Yeah.
That is awesome. Very inspiring. First of all, I love it for a lot of reasons, and I don't want to go too far. I want to think of my listeners here and their interests. But so what do you and other tools you use? Like, how do you manage the sprints? Do you use stories? Do you use something like Jira on the software side? Is that something you're using?
So our software team is pretty small. There's only 2 people, so they kind of work together, and we use GitHub for a lot of our kind of
Okay, GitHub.
yeah.
Yeah.
And on
Okay.
the hardware side, we're Onshape users, so we have our version controls.
Okay.
I actually have a funny story for you. We previously were not Onshape users, and then we attended the Robotic Summit in 2022, and you were speaking about
Oh, yeah.
Onshape, and that is actually why we just switched over, was because you had
Oh,
mentioned
yay.
all the concerns we had about some of the security and some of the features. We gave it a shot, and so we've been using it for the past couple of years. Now part of your startup program, so we've been
Oh,
proud
that's great.
users ever since.
Yeah, well, I'm happy to hear that, of course, and not the focus of the podcast, but good that you bring it up. But it is interesting because we're seeing. I'm just going to note to you and our listeners that I'm seeing a lot more what I'll call agile process coming to hardware, and I think it's an interesting trend. I just co-authored a white paper on the subject with Professor Stephen Eppinger at MIT, who's seeing the same thing in his corporate consulting. So big companies want to work like you. Like some of the biggest companies on earth are coming to Professor Eppinger and coming to us and saying, we want to work like, they don't name Tatum Robotics, but we want to work like a startup. We want to do weekly sprints. We want to have, agile, be very agile. But let me get back to the product, which is so amazing. You mentioned Mass Robotics, great organization for people out there who don't know. You can Google search at Mass Robotics. Tell me, what is Mass Robotics meant to? You mentioned access to the 3D printing machines, but what else has it meant being part of
Yeah.
it?
So as soon as actually I graduated and decided I was going to create this company, I really didn't know where we were going to sit. We're a hardware company. I can't do this out of my apartment anymore, especially as we built a team. And I had just happened to Google Boston robotics space, and Mass Robotics came up. So we've been here since day one, and it has been wonderful working with Joyce and Tom and Colleen. They're able to bring us to, that's how we actually went to the Robotic Summit, was because of Mass Robotics was able to kind of facilitate that. Went with them to Robo Business. They have demo days, bring in investors, which is great to just kind of talk about the business, learn more about some of the questions you're going to get asked. And it's really just a great community here. Everybody is very collaborative. We work with a bunch of different companies. If we have small questions on, power management, we can poke another team that, they've already solidified theirs. They can now work as support. So it's been a great community, and we are very happy to have been here for the past couple of years, and hopefully many more to come.
Well, that's great, because you're not just a product developer, you're an entrepreneur, as many product developers are. I've interviewed and I meet many entrepreneurs, but also some of our audience are entrepreneurs. Some are what I'll call intrapreneurs. They're in a big company, but they're acting like an entrepreneur. They want to do something new and different. Would you advise all of them to seek out, if not Mass Robotics, something like it in their community if they have one?
Yeah, I think especially for first-time entrepreneurs, I think it is exceedingly helpful just having a community. I think entrepreneurship can often be a very lonely journey, and having a community around you to ask your questions, to show that, even this question you have, somebody else had that question a month ago. These are common questions, and there are resources and answers for you. And I think it's also helpful as we grow a team to be surrounded by this community. Now we have these resources. We don't need to spend our small budget on all these 3D printers and CNC parts. I think we can spend that on a growing, talented team instead. So I would say that it's been very beneficial for us. And, the WTWH team has been wonderful in allowing us to have that exposure and going out into the community. So I would promote it to everybody, and I already do, and I'll do it more.
You said the W2, can you say that again?
The Willing to Work Harder team, the one who puts on the Robotic Summit and the Robo Business Summit and all the.
Yeah, just to note that's, just so people know, Robotic Summit in Boston, and it's annual event, I believe. Fantastic event. And I see you're getting a lot of media recently. You were on Robot Report podcast, is that right? Did I see
Yeah,
that? I'm looking at
yeah.
your
So
website
we
now.
actually last year at Robo Business, which is out in Santa Clara, we won their Pitch Fire, which is a pitch contest for startups. So then we were Mike and Steve invited me on their Robot Report podcast to kind of speak about our product, the win, and just kind of the general thing about our business.
That's great. You mentioned 3D printing, additive manufacturing for prototyping, but when you're in production and selling the T1, are there going to be parts on it that are 3D printed in the
Yeah.
production deliverable? Yeah.
Absolutely. So we definitely have some components that, we started 3D printing and now we're either molding or machining. But there are some elements to the part that, they can remain 3D printed. It keeps it, low cost, it keeps it lightweight and allows us to iterate on it if it needs to, especially when we're still in these early stages of launching. So I think that 3D printing, more and more we're going to see it in these launched products. I think as the technologies improve of the parts in the material properties of these things that you can now 3D print. So I'm excited to see kind of what we actually can maintain 3D printed as we move forward.
I totally agree. I think 3D printing is a field that essentially is reinvented each year as our colleagues who are building the printers. I have many acquaintances in that industry, friends in that industry, and not only the printers, but the materials are huge. And of course, the tools to design with and the culture and knowledge of it. It's just all moving ahead. And so it's so inspiring to hear you're using it for end user deliverable parts as well as inside. I want to say time's flown by, Samantha. I could ask you questions all day, but I want to say on behalf of all listeners, a big thank you, Samantha, for joining us today. Once again, I want to tell everyone our Masters of Engineering podcast, our guest today, Samantha Johnson, the founder and CEO of Tatum Robotics, building the coolest robotic hand communication device for deafblind, the deafblind community. To our listeners, I want to thank all of you for listening or watching. If you're on YouTube, you can watch our video or just listen wherever you get your podcasts, Apple Podcasts, Google Play, Spotify. You can subscribe and hear other episodes of Masters of Engineering. If you want to learn more about Samantha or Tatum Robotics, you can go to their website, tatumrobotics.com. Also, Samantha tells me they have Instagram at Tatum Robotics or on LinkedIn. So definitely easy to learn more. Certainly, if you know a deafblind person or organization, boy, I would think you'd want to point them Samantha's way. I certainly will. I know someone affiliated with the organization here in Boston, and I'm going to recommend it. I also want to mention, I love hearing what you think of this podcast. So make sure you leave a review of this episode. Tell me what you thought of Samantha and her story. You can follow me on Twitter at jhirschtick, JHIRSCHTICK. Samantha, so great to finally meet you in person digitally. Hope to watch you do wonderful things with Tatum. That's it for today. Thank you all. See you next time on Masters of Engineering.